All right, so welcome aboard. This is your second session. So the first session was for everyone to watch on their own. And if you haven't watched it, you can still go back. We encourage you to go back because it'll probably explain more to you about what's happening in each of the sessions and how we've broken them down. And just as an FYI, it is going to be laid out a little bit differently for those of you who've joined us as a repeat. We're not going to kind of have all the concept and materials up front and then all of the resources and the sort of the unit planning that I did in the back. We've intertwined those so that it makes more sense for you to see how and what information I'm giving you links directly to what Ted is going to unpack as well. So we're going to tag team back and forth and make sure that we can kind of make those links for you as well. All right, so we will get going and we're going to start with our land acknowledgement. But before we do that, we're actually going to start with a quick video. And the video will link to actually the living systems that we are talking about right now. And we'll always try to pick something that will link to not only the organizing idea, but sort of the theme that we're about to unpack with you as well. So before we do our land acknowledgement, we're going to do that. I'm not going to watch the whole thing with you. I'm going to fast forward it through once we get it up and running, and then I'll stop it before it ends.
What is Indigenous worldview? What is worldview in general? Why do Indigenous people Indigenous worldview? So let's talk through the basics. The first thing you need to know about Indigenous worldview is what the heck worldview even means. Now, what is worldview? I know I already mentioned what worldview has to do with different perspectives on the world, but let's define it even further. A worldview is a collection of attitudes, values, stories, and expectations about the world around us. These inform our thoughts and our actions. Our worldview is expressed through ethics, religion, philosophy, beliefs, etc. Overall, worldview determines how people live and how it can be shaped in any number of things, including ancestry, community, and social structure. Worldview is also how we think about our relationship between ourselves and other living things. You have a worldview that shaped you and has determined your beliefs. In the same way, Indigenous people have a unique worldview that influences absolutely everything we do. By learning about Indigenous culture, traditions, practices, and teachings, you are engaging with an Indigenous worldview. So let's talk more about that. The second thing you need to know about Indigenous worldview is the fundamentals of this worldview. Now, what is an Indigenous worldview? The guiding principle of an Indigenous worldview is that all living things are connected. Appreciation for all living things is a prominent Indigenous value which comes directly from the Indigenous worldview. Indigenous people live their lives under the principle that all living things contribute to the circle of life equally and should be acknowledged and respected as such. Indigenous people believe that the connection to ourselves, to the Creator, to Mother Earth, and all living things are integral parts of existing. That is why the land and other natural life is so important to an Indigenous worldview. Understanding that all living things are connected and that everything plays an important role in the world is an integral element of an Indigenous worldview. These principles are what guide the teachings, beliefs, values, and practices of Indigenous communities. Now, the third thing you need to know about Indigenous worldview is how it differs from Western worldview. Now, how is Indigenous worldview different from Western worldview? Most commonly, Western worldview is based on the assumption that man is superior. Instead of all living things being equal, living things are structured in a hierarchy. An Indigenous worldview is based on the idea that humans are equally important to plants, animals, and all other living things. Western worldview traditionally treats humans as the top of the hierarchy and everything else falls below them, which shapes the way we treat plants, animals, and nature. This often leads to misusing, mistreating, or disrespecting other life because it labels humans as most important. Indigenous worldview can be visualized as a circle, while Western worldview can be seen as a ladder, or a collective outlook versus an individual outlook. This structure
Okay, so I'm going to take us back now to our recording, or to our session here. Okay, we'll get rid of that. And let me just grab this quickly and bring that back up so that you can see it a little bit better. So what we'll do now is just start with our land acknowledgement. And from there, I'd like to move on through the slides that we have for you and keep going. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten.
What is Indigenous worldview?
Let's carry on here. So as we're going through our sessions, you're going to see a table of contents in each one that we do. And really that table of contents will be very similar in each one, but we'd like to give you backgrounders, conceptual overviews, like what are the big rocks? What are the concepts that live in what we're about to unpack with you? And then looking at the skills and procedures. And in between those, maybe giving you some instructional strategies that you would be able to use, any that I have within my unit that might fit into that that gives you as an exemplar. And then we'll look at unpacking the understandings, or which are kind of the most important pieces that go along with everything that's here. So I'm going to turn it over to Ted so that he can start unpacking all of our pieces.
Thank you, Chris. I'd like to just begin with this graphic, and it sort of carries on from what Chris mentioned, that we're unpacking this curriculum a little bit different maybe than the way we have unpacked other curricula. And I like using the analogy of a smartphone, maybe just to help calm everybody down a little bit, because we're talking about concepts and things like that, like what's going on. You know, when the smartphone first came out, I know there's some early adopters. We all know that had it, and for the most part, the first smartphone was simply that, a smartphone. And then those of you who had the flip phones, if you had that at any time, you would have a novel thing that had the potential to actually text. But as time went on, you know, the smartphone came along, and now it was connected to the internet, and some amazing things happened. We were doing searches, we were doing all kinds of things. There still were, though, and they still are, you know, I think I know of examples, but anecdotes are only one thing. But there are some people who still they're afraid to use the phone for anything other than a phone. They don't know what to do. They don't know what's happening. But we know that the potential is there, and understanding the potential of the smartphone and what it can do is moving it forward. We know that it not only just has can phone, but it has all the contacts. And how many of us memorize a phone number anymore? We don't do that. We know our little black books with all those phone numbers in there. It's just the potential is there, and now look at all the apps we're getting on the phone, and I'm sort of in that middle phase right now. Right now, there's people making their own apps for their phones and making it so their phones can do things. It's quite an amazing potential in that smartphone that we have. But we're all on this journey of having a smartphone and using it for certain things on our own way. We begin at a certain spot and we're moving forward at a certain spot based on our comfort level. But just knowing what the potential is and knowing what other people are doing with it really helps us to move forward. And that's, in a sense, the same with a curriculum, with any curriculum, really. We can go to the next slide, Chris. You know, our old ways of teaching us, these are old ways, I'm talking about me, was we taught in silos. And you could see that example on the left, the very far left. Our old science curriculum had topics. They were just distinct units. We taught them in isolation within the grade, right? We did this unit and we did this unit, this unit. Once in a while, we refer back to what we did the unit, but there was no cohesive connection between them. You'll find this particular curriculum that you could easily do that. You're revolving between ideas and some of the we call the concepts in one unit into the other. So that's where we're at with the revolving thing. The potential is here is that when you introduce something in one unit, you get to come back to it, whether it be a skill or an understanding, it interweaves with all of them. You'll find the example with computer science, for example. In some of the skills and processes of computer science, we'll find are useful in living systems. They're useful in other organizing ideas. When we take a look at even more of that potential, and I guess when we take a look at that, boy, isn't that nice? We don't have to, that we can use the same ideas and skills and different organizing ideas. The amount of comfort level that these kids will have and mastery over those skills and those understandings is huge. And the potential even more. It'd be great if we to use this kind of an approach using concepts when we're talking about maybe split grades. It'll be a lot easier to work with split grades because some of those concepts and skills are umbrellas and they could be worked out with each grade. Or if you're working in a larger school where some of you are teaching different grades, maybe you get together with the science teacher, the social studies teachers, the language arts teachers, you'll see that when we take a look at the curriculum closely, there could be easy tie-ins with other subjects. Are we going to do that today? No, I'm just opening that potential. If we're at the beginning and we want to take the resources that Chris and I have available to you, and you're still at that stage where you're kind of, you're going to be giving kids the activities and here's the things to know and everything, that's where you're there. But we really want to open your eyes to the potential of moving forward. And you're not going to move forward all at once. I don't think anybody expects that. Just knowing where this is heading to help you experiment a little bit, to try some new things, to move forward so that the full potential of not only this curriculum, but any curriculum can be met to its fullest potential. So that's where we are. We don't want to scare it away with all the big ideas and talking about concepts. We know where you're at. The point is that move slowly. You can have a larger vision in mind at the end of this all. Not only will we as teachers benefit by moving forward like that, but the students as well. And that's where then we talk about the surface deep and transfer learning. Don't confuse this graphic with the other one. This is just talking about the different phases of learning that we're with the way Chris and I are looking at this curriculum. That at the beginning of each cusp, we're going to be looking at what is the surface level things kids need to know to be successful, to gain that understanding. The surface level, again, of those skills and concepts. The deep level is the understandings, and the transfer is when we get kids to take their understandings and their skills and use them into new situations. And that's how we are viewing this curriculum. And that's the power that it does have. That's the potential of how this curriculum is structured. I'm not talking about the content, but the structure that can really help us move that way. The content helps too. Go ahead. So that's why we're beginning with the conceptual overview, because the concepts themselves are really the nuts and bolts of this curriculum, or the way we're looking at this and unpacking it for its full potential. Concepts are replacing the word, I think, vocabulary. We can go to the next slide, Chris. Yeah, we've often used science vocabulary, and you all can think of some of the vocabulary that's important to your science courses, maybe habitat, or you could think of some others that you have kids remember the definitions for, and so on. We're going to change that word from vocabulary, from the science vocabulary, to the concepts. And a concept is simply an organizing idea of 1 or 2 words, like fruit. It's an organizing idea. It's an organizing idea because there's many examples of fruit underneath that idea. All these things that are examples, such as the pineapple, banana, and the apple, they have those distinctive attributes that make it belong to the category or concept of fruit. And there's multiple examples of each concept. And that's what we do. We take examples of things, we put them together, they fill under this umbrella of a certain concept. Just maybe some other ways to help you understand concepts if it's new to you. They're really a way we organize our world. We have schema built in our brain, and we have the broad ideas and things narrowed down. When we go into a room full of furniture, we don't scan the individual pieces of furniture. We're able to categorize all those pieces that might be furniture and so on. And we can talk about that. Concepts is another maybe analogy, or like file folders on our computer. We give it a name, we give it a title, like a concept name. And all the examples are really the things we put in that file. Everything we put in that filing folder have the attributes, assessments, for example, that would make us put it in that folder. And when we play I Spy with My Little Eye, something that is red, something red is a concept. And there are many examples of things that might be red in a room, and we're having people find that one that shares that one attribute, which is the color red. So concepts are the foundational things to the curriculum. And just to have you, again, explore the idea a little bit and look for different concepts. I have a picture here of Mount Everest. You can, I don't know how clear you could see it. What I'm going to ask you to do is just pause and take a look at and see if you can name some concepts that come to mind. You can kind of see there, if not literally see them, it is an example of a concept that you understand. And feel free to put a couple in the chat box if you want, if you feel comfortable doing that. I'm just going to give you a minute, or not even a minute. We'll just take a few seconds for you to start typing some things in the chat box if you feel comfortable about what kind of concepts you might see here. One I see is, I could see landforms. Waste. I could see interaction between the mountains and the sky. We've got the clouds there. Caring for our world, and in this particular case, right, lack. So care is a concept, and we could see that here because there's a lack of it. Thank you. So there are multiple examples. I see what human influence, exactly, human influence, climate, perfect. Those are all things that we could stop. If someone asks you, what do you mean by climate? You'd be able to explain. If someone asks you about human influence, what is on landscape? And the two different things, we'd be able to explain that. So thank you for sharing. Rocks, minerals, absolutely. So we're going to just, as you go through the curriculum, and you look at it carefully through that lens of concept, you'll see a whole bunch popping out at you. For example, story is a concept in this part of the learning systems curriculum for grade 3. It's there. What I ask you to do is scan over it if you have a hard copy, or if you're looking on the screen, if you have something available with you, scan over it and see which words you'd identify as the concepts in this organizing idea, or at least this section of the organizing idea. I'll give you a few seconds and I'm going to pop up one that's kind of pre-selected for you. If you were looking carefully, you'll probably notice that, there we go, that many of the words in this organizing idea are highlighted as concepts. But the other thing you'll probably notice that many of them are repeated: plants, animals, representation, represent, food change. Those give you an idea that those are really the big ones that are going to be worked with in this organizing idea, and ones that you'll want to make sure that the students have a chance to really explore and get a good depth with. We'll talk about what concepts might have been really treated in grades 1 and 2 prior to this, and you'll see that as an example of how concepts learned in one grade keep on moving up to the next grade, and we keep bringing them back together in a spiraling fashion. Go ahead, Chris. If we were to take all of the concepts and ideas in this organizing idea, they would appear in a concept map similar to this, perhaps. I put this together just to give an example of how the ideas in a concept-related kind of curriculum can be put together to draw a picture. In this particular case, I'm going to draw your attention to 2 left-hand squares there. Those, in a sense, are the starting points. They both have little white dots on them, and I'm just going to begin with the green one to give you an example of how to read through this to help you get a better sense of what this organizing idea is about. And beginning with the green dotted one on the left, we can read that human behaviors, I can't read it too well, it's not very clear, can provide protection when they understand the interactions of plants and animals. You know, plants and animals interact in environments as they are dependent on each other for their needs and so on. So you can see it when you have a clear copy, you'll be able to read through it and get a sense of what this organizing idea is about. You will have a copy of this concept map in your resource packet when it's posted on the website, I think by tomorrow.
And just to follow up with what Ted has just shared with you, it's really important, even in the session 1, we had pointed out that, you know, the curriculum is not to be designed as a checklist. And so you can see these connections that he's created. It's not about teaching all the greens and then saying, yep, did it. And then I'm going to do all the light blue ones. Yep, did that one. It's about teaching those and then making the connections between them so that the students do see how these are all influencing one another. They're not standalones. Because if that's all we do, then we're just staying at surface level. We're just testing factual information. but we're never giving them an opportunity to really combine their concepts and apply it into situations. That's really our goal.
Because we're looking at this curriculum through the lens of concepts, you'll see that when you do take a look at the living systems from grade 1 to all the way to grade 6, there is a connection and a continuity of a lot of those ideas. In grade 1, we talk about living things and plants and animals and how they survive. In grade 2, we talk about how plants and animals survive by going through the life cycle as a general way of looking at that grade. And in this grade, we're taking a look at how living things survive through a food web and through that whole notion of interaction with each other in the environment. So once again, you can see how that connection keeps on rolling through the curriculum at the different grade levels. Now, I brought a whole list of key concepts here. Now, there's a whole big list there, and that is, again, the nature of the curriculum. They're not all introduced necessarily at this grade level. You'll see that when Chris and I go through the curriculum, and Chris, especially when she shares all your examples, she's going to be making references to all these concepts. And if they're not familiar with the students, they're going to have a hard time. So I just wanted to identify that these are the key concepts. We're going to show you how we can work with them. But the next slide is going to show you an interesting thing as well. Up until this point, even though they're all essential for our working through this curriculum, it's the pink ones that are really new to grade 3. So by this time, the students will have developed these other concepts. So when we work through this, the examples, just keep that in mind. You won't miss to see examples of everything being introduced because students by this grade will have learned them already, but you may have to do some back teaching. I'll just point out that senses is used in this organizing idea, but it is not, it's introduced in kindergarten matter. So you have to keep that in mind. So you may have to do some back teaching there with senses. So what Chris and I would like to do now is we said, remember, we're taking the learning phases, we start at the surface level and then we go through the deep level where we're looking at the understandings and then to transfer. We're going to share with you a lot of surface level activities that you can do to really help students understand the concept, not just at the definition, the one-dimensional definition level, but moving it forward into creating examples of that concept, seeing examples of that concept like in the picture we saw. If you understood those concepts, you could identify them. We know what waste is, you could identify in the picture. If human interaction wasn't visible there were no humans, but there was evidence of there. So the more conceptual understandings kids have, the better they are to interpret the world. So this is why we're going to work at the surface level here. And one other point, we're going to share with you lots of activities about how to teach the different concepts, but the expectation is to not teach all the concepts at the surface level all at once. Take a look at the cusp line, see what your end goal is, and you'll see when you look at the cusp line, okay, these are the ones that are going to be important to get to the understanding and to work with the skills. So these are the concepts I'm going to focus on first at the surface level, then go to deep and transfer, and then come back around again as you're working through another cusp. Just so you don't do them all at once. So Chris, I'm going to hand it over to you. So we're looking at some instructional strategies that are really helpful to develop those concepts at the surface level.
So some of the examples we'll give you are ones that I've been using in here. And so we're not going to necessarily unpack everything, but card sort is one. And that might be new to some of you as a strategy for introducing a new topic. But for me, I see it as one that I get a lot of feedback from what the students know. So anytime that we're teaching them something new, we also need to do a little pre-assessment or know where are we actually starting with them. And a card sort gives me the opportunity to say, here's a bunch of pictures or words, depending on what I'm going to give them. And I might give them very open directions of just simply sort them without saying how they should sort them. And then having them give us the feedback as to what was the determining factor? What was your rule for putting all these ones together? How did you know to put all these ones together? So living systems is one of those units that card sorts work really well, just given the nature of the concepts that we're unpacking. I've shared with you a number of the card sorts in the folder, but a number of them are starting from grade 1. And we're using the same one over and over and over again, but it's also important for you to know what did they sort in grade 1, because They're not going to land at your doorstep next year with all of the grade 1 and all of the grade 2 fully intact already. So you're also going to have to do just a little bit of legwork to go back and say, I need to bridge a little bit on what was happening in the grade 1 just to see where my students are at. I'll pick up a few things from grade 2. And then I can start using the same cards, so we don't have to change them, for the things that I want them to really unpack for me in grade 3. And the advantage of that, excuse me, is I get to see the pictures over and over, but now you're asking me to, every time I pick up the pictures, just like the mountain, I'm looking at them through a different lens. And now with a different lens, I might put them in different piles. And that's the power of a card sort. So in grade 1, they start with, there's no living systems in kindergarten, but in grade 1, they start with, do they know the difference between living and non-living? And so, of course, with the grade 2s yesterday, we said that would be a good starting point as well. Let's just know that they're strong in that sort first. So their card sort doesn't have any words, just pictures. We give them a sheet of paper that is titled Living and Non-Living, and we just say, can you sort the cards? And then talk to them about, why did you put what you did where? What were some of the factors? What are some of the relationships? What are the things that you're seeing in common with the living ones? What are the things that you are seeing in common with non-living? And how were they different? Because in grade 1, we also talk about what are the basic needs an animal or a plant needs to survive. So that's going to be important that I know it's living. And now that I know it's living, what do all living things need that are in common? That's another piece. So just asking them, what's the relationship between the things you put in that column called living? What were the relationships between the things you put in the non-living column? And then maybe we can talk about some similarities that they see and differences or not. You know, they're not seeing them. Then we went one step further, because now we start to unpack, both in grade 1 and in grade 2, animals and plants. We look at them a little bit differently, but really, again, the basic needs of an animal, the basic needs of a plant. Well, there is definitely overlap there. And so we ask the students to actually identify what do plants and animals need that's in common, and then how are they different? What parts of their particular characteristics would be different? So again, there's some other strategies that we can use other than card sorts. You could even combine the card sort with another strategy. But in this case, we asked them to not only tell us which were plants and animals, then we went one step further and said, could you take the animals and put the animals into groups of their own? How would you take all the cards of the animal pictures, and would you make different groups? And if we put the plants in there, would you make different groups with them? So in this case, one of the groups, these are the animals that they put together. The plants are here. They've got animals down here. They've got animals down here. So then the question has to be, don't just do it. Don't just say, okay, they sorted. We still need to talk to them about, how did they decide what was there? So in this case, we looked at the number of feet. The students said, well, everything that's in this group has 4 legs. Everything that's in this group had 2 legs or 2 wings. This group up here, these were the plants. They had no legs and they had no movement. But the group down here, they had no legs, but they were moving. So they had some really good strategies for how they broke these out. And then we could start talking about where are the similarities between any of the groups, what are the differences? And then you might even extend this. You know, we said to grade 2s, what if you brought in some additional pictures now? Like, what if you want one of those great big centipedes with 100 legs on them, right? Now there's something different. That didn't fit into one of your groups. So how would you talk about that, right? How would you talk about spiders? They don't have 4 legs, they don't have 2 legs. How would you talk about flies? Like, all of these could be brought in and added as an extension to what they've already learned, just so that we're getting a good sense of where they're at. Another one that I do like to use is a case study. So I might say to students, I'm not going to tell them anything. I'm not going to give them any of the card sorts right up front. Maybe I'm going to read them a story. And in this case, I picked one. There was one in the, you have access to the grade 1 and 2 folders as well. But in theirs, we looked at what's living. Is it alive, right? That was one of the books that they read. But we could also ask from the perspective of, in grade 3, I'm starting to look at a food chain. And before I even get into the conversation of food chains and all of that kind of stuff, I might simply say, you know, maybe I read the story, Who Eats Who? And we just read the story and we ask, what have we learned from this story about plants and animals? And are there any animals that eat certain foods? And then hopefully they're going to identify that some animals eat other animals and some animals only eat plants and those types of things. We don't have to get into all the terminology right away, but this is a case study. We read it and then we discuss it. And then what should we learn from that to start the conversation going from where we are without giving you definitions on the board, anything like that. So this one is a great little story. It's a 5-minute story, and the book Who Eats Who is actually read out so that, again, the kids can listen to it if you have a center. But this is a great one to do as a class. If this is my starting point, I'm using a case study to start, then that's where I want to go. A Freyer model, that's another one. I think a lot of you know about those as well. Freyer models allow me to give you lots of opportunities to learn. I did the card sorts, but now I might want to say, I just need to know, just a quick check-in. Do you really know about the differences between plants and animals? Do you know the difference between living and non-living? Do you know the difference between the different classifications of animals of who eats who? Okay, that would be something down the road that we could do. So again, I might use a Freyer model, which allows them to simply say, it is and it isn't. This is what it is. This is what it's not. Give me an example of one. Or maybe I put a term in the center of my map and they give me an example, give me a non-example. They could draw me a picture, they could give me some other, they could write something about it. So again, it just unpacks for me what they know and for themselves what they're able to do. So there's a template that you can use in here as an example. For the grade 2s, we did a Freyer model. We suggested that they talk about human relationship with land can be both positive and negative. We were talking about clearing the land. We can clear the land, which is good because it gives us more arable land if I'm a farmer to farm and to grow things on. Bad if I'm looking at plants provide us with the valuable oxygen that we need. They provide us with wind barriers when we live in flatter places. If we cut all that stuff down, we're losing it. So pros and cons for doing exactly the same thing. Hey, Ted, if you want to talk about concept attainment.
I got it. My mute was on. Concept attainment is one, again, a strategy that you're likely familiar with. This is one of those activities where you give examples and non-examples. You have a concept in mind, and you give yes examples and no. And as the examples appear, students look at the similarity of the yes column to think, well, what is that attribute that they all have in common that make it part of that, that make it that concept. Now, there's a whole bunch of concepts there that have developed for you that are concept attainment activities. Some of them are going to be very useful for the content part, and some will show up a little bit later. But I think a couple of the key ones that are, if I was going to suggest them, is to take a look at the relationship one, and then the cause and effect one, and the dependence and interaction in that order. To develop those concepts, they kind of work together nicely, and I'll show you what I mean. I'll do you a quick look at the cause and effect one. At this point, if I would have done a relationship concept attainment with them, or they understand what a relationship is. And now I want to get into, well, some relationships can be a cause and effect relationship, right? And if that's the case, then there's two things kids need to distinguish between as cause and effect. So I'm going to just quickly go through the slides, Chris. I don't want to take too much time. And all these is a little explanation of what a concept attainment step or lesson involves. And so we begin going through examples and non-examples. Go ahead, just keep scrolling, Chris. Again, they shouldn't. They should know what they should know what a relationship is prior to this. Okay, and they use that one first. I'll show you why. So you give examples, non-examples. In this particular case, Group A is going to be the cause, and Group B is going to be an effect. But as you see them lining up as you go through the slides there, Chris, you'll see the general sense that, okay, these are examples. The sun was shining brightly, I put the sunscreen on. The ball was coming at me, I ducked. And eventually students see the pattern that, well, whatever happens in Group B, there's something there. So that would give, where would you put these examples? As I drank some water, better belong in Group A or Group B, and same with I was thirsty, where would they fit in? And clearly we'd put the I was thirsty in Group A, So I drank some water in group B. And what they all have in common is that the things in group A are things that happen, and in group B, they're things that we do because of group A. They may not word it, give it cause and effect, or they may already know it. So we can go to the next slide, Chris. That's where we give it a name, cause and effects, and we define it as it's defined there. So once we get those ideas, if we can go on to the next slide, Chris, then we can give them practices, right? Here's a situation, what might be some causes to this particular situation? You have all kinds of different triggers if you want, but keep going. You can also do a similar thing, same situation, but what might be effect now of that particular thing? And just giving kids opportunities to provide examples, non-examples. Now, here's a really good one to get kids start thinking about making concept maps, because then you say, well, put something at the front here. Maybe it's, I dropped a glass, and then what would be the effect of that? It broke. And so we'd have two things in the middle, but now what we have to do is put in, and this is what is taught in the relationship concept or lesson, you put in a connecting word. I dropped the glass, therefore, or the result was it broke. And if you just go through the practice, Chris, you'll see that. So dropping a glass causes it to break. Something is an effect of something else. And you can see how you can establish those cause and effect relationships. And then you can give them the thing, here's a bunch of things, put it together in a concept map, right? And that might show cause effect relationships. I broke my foot, so the effect of that is I can't play soccer, and I do all these things. And you can even move forward through this to show what impact was. We're not going to go through it, but you can see how they're just by going through little examples, non-examples, you can get kids developing some concepts at a pretty at a surface level. They'll need more practice with them, but these are just a nice way sometimes of introducing those concepts if you don't think they're very sure about them. So what's something that's a negative example versus a positive effect versus a positive effect, and so on. But I even get into the impact, because effect and impact show up quite a bit, but it's no in the curriculum, but there's no real point in which it's really defined and taught to the kids. So it might be a really good idea to put these in there, because throughout this curriculum, we're talking about relationships and impacts of human behavior and the interconnectedness of things and so on. So that's one way to teach things at the surface level, is through a concept attainment lesson. But we'll move on to some other ones. There's a whole bunch of there that you'll have access to and links to. There'll be some there. You'll see the conclusion, analysis, criteria, prediction. Those are all part of the investigative process in the scientific methods. Again, they're a concept that kids need to understand in order to do an investigation. So that can help when you get to that point in the curriculum. Thanks, Chris. Oh, I'm still on with skills and procedures. At the surface level, in other words, before you're at that cusp and you see, well, kids are going to have to do this in order to show their understanding, whether it be discussing or they're going to compare and contrast. You want to know what that skill is as you get going, so you can give it a name to the students. You can tell what it is. This is a sort, and we're classifying things. Give those things names. And then if it's an unfamiliar skill or new, go through the steps. Here's how you do this. Here's how you do an investigation. Here's how you compare and contrast. Here's how you make an observation with your senses. And then practice it till they become more independent, and they can do it in a context outside of the course context. So when you ask them to do it with the course material, they're already familiar with how to make an observation or how to do an investigation, and they're focused more on the course material than the skills. That's where we're looking at developing things at the surface level. So go ahead, Chris. We're going to take a look at some of these here. Although what we've got here then are the skills and procedure statements for each grade, or not for each grade, for the entire living systems organizing idea. I've highlighted those verbs, which really are the skills. And I just wanted to remind out with what the meaning of skills and procedure is in the guiding framework for the curriculum. It's skills and procedures are what students do to demonstrate their knowledge and understanding. So there's two parts. So if they're going to demonstrate their understanding with the skill, they need to be fairly good at that skill. Otherwise, they're not going to demonstrate to you fully what they understand. So if we go to the next slide, Chris, the key ones for this organizing idea are listed in the next slide. Not so much compare and contrast. It does show up a little bit here and there, but represent, investigate, discuss, and classify. Those are ones that do appear, and they're really, they appear in grade 1, kindergarten, grade 1, grade 2. And if everyone was to just take that moment and stop and say, okay, if we take a look at discussion and work with it through the grades, we'll be able to, by the time we get to grade 3, have a little bit more I guess, purposeful approach to discussing, because it's a powerful strategy. Go ahead, Chris. One of the strategies is the direct teaching of skills strategy. When we do an investigation, you'll see that there are 5 steps. So it's just breaking a skill down to its steps, making sure they understand any concepts in the steps, and then practicing those steps. And when we get to computer science or scientific methods, you'll see how that breaks down. But they're directly saying it. This is investigation, and here's what we have to do to investigate things. Here's the steps. Go ahead, Chris.
And so just following on the heels of what Chet has just said, we could do something like, again, at surface level, what do living things need to stay alive? So we talked about basic needs. What are they? Define them. Tell me about them. And again, I could use a directed teaching approach. I could use a story approach again, and then from that story, what have we gleaned? What can we say that we've learned about that skill of need for living, any living thing? I might even do just a read aloud where the kids are revisiting some of the things, and just to verify that they understand some of those key concepts. So when I'm doing some of these work, I might use that. I might use my card sort and combine it with a Venn diagram. And I just want to remind everyone, it doesn't matter whether we're teaching science, math, any subject. A Venn diagram is what research says one of the highest ordered skill assessments that we can use for students, because you can't give that to a student who's just memorized a fact here and a fact there. They have to have some skill and some foundational knowledge that they can make some comparisons to. And that's the purpose of a Venn diagram, is what are unique characteristics of 2 things, if I'm just using 2 or 3 circles, whatever. And then what do they have in common? And that doesn't come from surface level teaching. We teach the facts at surface level, and that's where I'm going to start. But when I want to start really elaborating on that and making sure that they can apply it to a situation that I didn't give them in class, that I could give them a different story and they would come up with the same conclusions and being able to do the same strategies. So in both grade 1 and in grade 2, we use hula hoops. Hula hoops are great Venn diagrams. A, it gets kids out of their desk. That's why I like them. And B, they give them space. I could use a card sort here and say, I'm going to give them titles. In this case, we gave them plant needs and animal needs. This was the very first one that they did. So we put the word both in the middle, but I would never do that after the first time. That's what the kids should start to learn on their own, that this circle was made a here and this circle, and these were overlapped. So there's a piece that sits in both of the circles. And what does that mean, right? That's an important thing for them to unpack as well, over and above just the concepts that they're learning in science. So in this case, they were looking at what are the basic needs. So they've got outside of here that animals exercise and that they move. Well, we don't see movement happening over in plants. So environment, they need a special kind of environment or weather. They don't get to put a zip up coat and put mitts and toques on. So they don't have movement. But in the middle, we were able to have students identify that they needed shelter, a place to live, they needed food, they needed air, they needed water. And that's very doable. This is doable from kindergarten up. This is not about, oh, my kids can't do that, they're too little. Nope, they can do this, they're good at it. And then once we've got them in these places, and maybe they have one that's wrong, but can they talk through with us? Why did you put those in the middle? Can you give me an example of how you knew to put shelter or food here? Like, give me an example of how you knew that for both a plant and an animal. What did they come back with, right? What's their justification? So again, it gets back to our thinking about how ready are they to move on to a new scenario. Okay, getting into the big important ones, which are the understandings.
So again, at the surface level, that's where we practice those skills and get a solid understanding of those individual concepts. And again, not all of them at once. because they all relate to an understanding. And we take a look at the understandings and shortly, that's where we start combining those individual concepts into what we do call the understandings. And it's just that we're now at the deep level, we can do that. So the next slide shows the understandings for this organizing idea. And you can see that all the concepts that Chris and I were talking about show up in those understandings. And once again, the definition of an understanding is that it's how facts and knowledge, in this case, concepts,
Yeah, thanks.
fit together in a logical and meaningful order. How they fit together. So here in the first one, we could see, for example, the concepts plants and animals developed at early grades, but Chris again had those nice reviews with the case studies and the sorts. Environment is another one that was taught from a different grade, but we want to make sure the kids know that through some back teaching review. Third concept, and the fourth, food chain. So we have plants, animals, environments, and food chain. So how are those connected? Well, one way to connect them is we could say plants and animals interact with each other in various environments in ways that can be represented with food chains. So you can see how the understandings take those concepts and put them together in something bigger than just the individual concepts. We get an understanding out of it. So the question becomes now, how do we teach to those understandings? How do we get to those? And that's what our next set of strategies are going to help introduce to you. One way to do that is by making concept maps, because really part of the deep process is not only knowing what those understandings are, but demonstrating and understand the relationships between the concepts. The deep part is really about the connections, making those connections. And that's how we move out of the silos. And I'll show you what I mean in the next slide. We can take a lot of these separate concepts. Kids might know what an omnivore is and a food chain is and an herbivore and so on. When you give them all these things together, they say, well, listen, how are these things related? That's when you're going to really see if they really understand the understanding. This is a good way to understand the understandings. Not only that, the concepts too, because if they put a concept in a relationship and they can't explain what it is, they may not fully understand that concept. So if we were to ask this, the students may come up with an example such as the one on the next slide, that interactions between plants and animals in environments maybe an example, maybe a food chain. And we know that animals can be herbivores, omnivores, and carnivores. And so we've related those all. And if there's some other concepts they've taken from some other organizing ideas or from other parts of the unit, then where would you put this in? Where would you put ocean in? To what concept did that fit in? And that's how we build that schema. That's how we help kids understand that just because we're going to take ocean, if we haven't already, and earth systems, haven't done it yet. When we talk about water bodies, they know that it's a type of environment. They can start making those connections. And so giving kids concepts really helps you to demonstrate what they understand, but it also helps you demonstrate some misconceptions they might have with the individual concepts. Go ahead, Chris. I think I've got a couple more. You see how discussing show up a lot in the skills and procedures. And it's such a powerful strategy, especially at this great age where kids are still maybe not being able to write their understandings very well and do that in writing. So it's the discussing, the talking part. So it's to do what I said, take that in that direct, explicit approach to teaching a skill. This is discussion. Here's how we do it. There's a discussion checklist. For a good discussion to happen, these things need to happen. You need to participate in this way. And giving kids on how they're discussing is so vital, because you'll see discussing going throughout the grades is a powerful tool. And research has shown that kids discussing their thoughts is an extremely powerful learning tool if they discuss correctly. And here's some examples how you can discuss correctly. It's not sitting in rows and everybody and just 2 or 3 people putting up their hand. It's putting kids in situations where they're discussing either in pairs or individually, or even with you as a teacher if there's 7 students who have a difficult time talking in front of other students. Give them as many opportunities to discuss and show how they can discuss in some of these different formats. Many of them you're probably familiar with. Same with representation. That's another powerful thing. It means as primary teachers, we do representing a lot. But again, if you're going to choose a representation, don't just have students do one type of representation. Give them some practice with it outside of the context. This next slide will show you what I mean again. We often get kids to do dioramas to represent. Well, don't think, well, okay, as part of my thing for living systems, they're going to do a diorama. If that's what they're going to use to demonstrate their learning, make sure they understand what a diorama is, maybe practice making one, so with something that they're interested in, so that they understand what the qualities of a good diorama are. So when they use that to demonstrate their understanding, they're demonstrating their understanding in a more profound way than not. Okay. And again, with any representation, if they can accompany with an explanation, it makes it even that much more powerful. And that way you'll know. We can even use those as assessments we'll talk about later. But Chris, you're on.
Okay, so when we look at the understandings, remember, this has now gone past just giving me the facts. Now I'm starting to get into how are they going to demonstrate this? This is really the crux of everything. It's the one that sits in the middle in our cusp, right? We have the knowledge on one side, skills and procedures, and you're not just going check down knowledge. You're not going check down skills and procedures and saying, okay, one and done. Now that they've got the content knowledge, now we start to combine and answer these questions. How will they demonstrate that plants and animals interact with each other in various environments? So in here, they're talking about food chains. So this is where, again, like to reuse stuff that we've already got. I might say, how do food chains, and I put this in brackets because in our pilot round, we had food webs. And we took it out in this one, but I'm really hard pressed to say, why am I designing all these food chains with students if they don't really see where the connection, not everything in the world is linear, and you know that. So I'm putting it in brackets because I think we should still leave it in. I wouldn't assess it, but I would say that a food web is just, you've made 3 different chains. How do they fit together? And I think that's a reasonable expectation, that we at least have that conversation with students so that they don't just think it's always going to be this, in that order. That's not the world that we live in. So, and they also have to know what are the names of some native plants and animals that live in Alberta. So wherever you live in Alberta, are there more prevalent animals that you see around a lot? If you live in a city, what are the common animals that they would see? And can they identify them by name? Like, it's not just that they know that they're there. So to start off with this, I might even just ask them, when you're hungry, how do you decide what you're going to go eat? And some of the kids have said, well, it depends on what's in the fridge, depends on what I'm allowed to have. I'm only allowed to have snack desserts on Monday, Wednesday, Friday, because that's our day that we're allowed to have treats, blah, blah, blah. Okay, lots of reasons that they might go and how they decide what they get to eat. And then discuss with your partner, make a list of some of the things that you think might give you reasons about what you would consider if you were going to go and have a snack. You're hungry. What's it going to look like? Maybe you have a specific allergy. Maybe you have certain medications you take. You can't eat certain things, but you like them, right? So those are the types of things. And then we might even extend that conversation to, how do you think animals figure out what they're going to eat? How do they know what they eat? Is it just whatever comes past me? Or would it be reasonable for a house cat to go after an elephant? They're really hungry? Clearly not. Size is an issue. So there are certain things that animals have to take into account when they decide what they're going to eat. So we could make a list of those kinds of things. What we're getting to is, we've learned about different animals and plants. We know about some of their characteristics. Now we want to think about, if I was starting to think about who in those pictures could eat who, or what would be a logical progression of food, this is where we're going to get to for food chain. So leading up to this kind of a conversation will help them. So now we're going to give the cards right back to them again. And you'll find that the cards, I have these cards in your folder, so you'll be able to grab them, but I put numbers on the cards as well. So those numbers match a list that is in the folder for the teacher. So if you're not sure what the animal is, these are all native to Alberta. So if you're not sure specifically which one it is, the name of those animals are listed by number in that other file. But in this case, we're going to ask them, familiar with the animals, you already know what's on there. But now we're going to ask them to use these 4 header cards. We know the name of what it eats. We know the name. Okay, we know the name of the animal and what it eats. We know the name of the animal, but not really sure what it eats. We don't know the name of this animal, have no idea, but we think we're going to make an educated guess that we think we know what it eats, and don't know it and don't have a clue what it eats, right? So we kind of covered all our bases. put those across on their carpet or wherever they're going to do it. And then which cards would they fit? And they may not have cards under every one because maybe they know all of them. Like maybe they are familiar with them all. So then when I go through and do that, then I'm going to give them directions, sort your cards, put them under each one, talk about other groups, like look at yours. What did you put in yours that you knew what they ate? Go to another group and talk about it with them. Maybe you'll get some learning from them that, hey, we know the name of this animal and we know what it eats. So then you could go back and resort. Now I've learned something, right? So we just do a little bit of work using those card sorts. Resort your cards into categories, explain your categories. How are those items that you placed, how are they related? And then we're going to get into, let's talk about what a food chain is. Now that we kind of have an idea of who eats who, how could we show that? And how do we show it? And what's it called in science is called a food chain. Who eats who? So in this case, I would always show and they need to know that the producer, the grass, the food, the real live green item always comes first because it has the most energy. So when we talk about energy in a food chain, the highest energy comes first. Whoever eats that directly comes second. Whoever eats that middle one comes third, and so on. Because each step, I lose more energy. It's kind of like I eat raw vegetables. That's the most value of nutrient I can get out of that vegetable. When I parboil it, not just absolutely kill it, I have some nutrients left, but I've lost some already in the cooking. If you just absolutely have to have it super soft and just really want to cook it completely, you're not going to have a lot of nutrient level. Well, the same thing happens here. I have the grass, the rabbit eats the grass. The rabbit's getting first crack at the highest energy that's available, which is in the greens. But it doesn't solely get 100% of every energy. Some of it only goes through its system, it's lost, it doesn't get absorbed. And then the owl, let's say, eats the rabbit. And they don't get full benefit of the rabbits eating the grass anymore because the grass is being digested. So it's always you're losing as you go. The more I have in the line, the less I have down at the end as far as direct energy. So this would be an example of a food chain. So you can kind of see where we're going to go. How can you take your card sorts? Can you make a food chain, right? So use your cards and create at least 3 different food chains. You might want to say they have to be 3 long. You might want to say 3 food chains. Does a food chain have to be 3 long? No, it could be 2 long, could be 5 long, could be 10 long. Challenge them. Say, can you come up with 3 different lengths of food chains? And then again, they have to explain how did they decide what went where? And then in the end, I would want to say that a food web allows me to take the chains and say that a hawk could eat a mouse, a hawk could eat a rabbit. So there's different lines that these lines could go and still end up at the same animal at the end. So that's the conversation. Animals can be classified. Not everybody's going to eat grass. The owl isn't looking for grass. The rabbit was though, but the owl's going to eat the rabbit is going to eat meat. So in this case, we want to make sure that we can classify those cards based on what they eat, not just who they eat, what they eat. So if I was going to reclassify them, I'd be looking at things like producers, consumers, and decomposers, right? I want to know what happens in a food chain. Producers are plants. They get from sun energy. They make their own food. We don't make our own food. We have to go get it, right? So green plants use energy from the sun to make their food. They're at the bottom of the food chain, but they have the highest amount of energy. We have consumers. Consumers go after something that's already been done. They hunt, they gather, they store food. Squirrels store food, they hide them. They don't always remember where they put it, but they do hide them. And they go back to get the food later. So they can't make their own food. And decomposers, they are the ones who take anything that's dead and break it down so we get the valuable nutrients put back in the soil again so that the whole cycle can start one more time. So those are really, really important in the whole cycle of life that we have. And the kinds of consumers that we have: herbivores, carnivores, and omnivores. So now I'm going to ask them to go back once we talk about them and resort. So can you find, if you resorted your cards and you looked at herbivores, which ones were the animals that were plant eaters? That's all they eat, right? They don't eat anything else. They don't go after a beaver. They don't go after a moose, whatever. Who just eats greens? Find those and put them under the title herbivores. Do the same thing with carnivores. Who only eats things like meat, right? So that's all I'm looking for. Bears, a lot of times people think bears are meat eaters. Well, they are, but they're also plant eaters. They love berries. They love certain roots. So those animals are called omnivores. And again, can you find those? Can you find them in your cards? And then do we have examples of decomposers? Did we have any pictures of mushrooms? Maybe we need to get pictures of mushrooms to put in there. So breaking down large molecules into small ones. Do we have worms that do that, right? So that's the part that they do. So these cards keep coming back over and over and over again. And then this is where I would definitely maybe take some time of the food chains that they've created. Maybe you could say, take two groups and put the food chains and how did they find any animals that they used in common and how could they make those lines happen so that they start to see that there are connections between them. And then I would even give them an actual finished one and say, could you write out what the chain would be? So if I'm going from flower to rabbit to eagle, if that's what it's going to be. So representing that flow of energy is really, really important. They need to understand it. They need to be able to design it, use the cards that they have. In kindergarten, they had a lot of different cards. They had cards that had live animals on them. It had hardware on it. It had non-living things on it. So if you need more cards, you could even grab the ones that are there if you needed more. So here we just contrast the fact that a food chain can be in a cycle. That's an important thing for students to realize too. It doesn't always have to be in a straight line, up or down or left and right. Sometimes just a simple goes in a straight line around, right? And it's just a cycle, but it doesn't break it. There's no things that go off as opposed to a food web. So again, I could look in here. Can you find me 3 different webs? What would you write out? Plants and animals have senses. Animals use their senses to learn when they need to change, maybe from one environment to another. We would ask them, what happens in spring? What do we notice sometimes when we look up in the sky? We see birds coming back. We see geese coming back. We see swans coming back. Well, where are they coming back from? And where did they go? Why did they leave to begin with, right? What was it that they found? Well, they knew that the change in temperatures, nights get cooler, days get shorter, is all part of a sensation and sensory that animals have that migrate. They know when that happens. Other animals have that sensory that they know when to get thicker fur because winter's coming, etc. Right? So we unpack how do plants and animals, how do plants know when there's a change in temperature, right? Again, they have a growing season. It doesn't last forever. Some plants do, some can stay through our winters, some can't. You may wish to look at senses. If your children don't know the 5 senses, hearing, touch, smell, if they're totally devoid of that, then you might want to go back into kindergarten in the matter section and grab the work that we did on senses. That's where that shows up. It gets revisited in a number of your other outcomes, and we do bring it in there. But if you were talking about they can sense something and kids say, I don't know what sense means, there would be some value in going back and just pausing what you're working on and just doing a quick, the 5 senses with them. So I've given you a whole bunch of different options here. I'm pretty sure this isn't going to all work here because I can't access all my moving forward, but we'll see. These are just videos that you could use. These could be used as case studies. You could use them different days of what are they looking for? They smell, they see, they hear. How do some animals sense that there's protection coming or a predator coming? So all of these pieces, this entire page is about resources for you. How you unpack it will determine whether it's at surface level, just factual stuff, or are we going to already combine it into some thinking, some deeper thinking that we want them to do.
Which animal has...
Oh, there we go. Got through that one fairly quickly. So home of our plants and animals, again, because we have to identify what are some native plants and animals in Alberta, we should also maybe just talk a little bit about where do we live? Like where kinds of places do we live? Some of you live in the mountains. Some of you live on the prairie. Some of you live in a very hilly forested area, right? We all have different locations around us. What's our location? What's our animals? But then let's study another one that we don't live by. Let's go talk about the mountains. What lives in the mountains and how is their environment different than ours, right? So we can have those conversations. And then maybe here's a transfer one. It could be surface level for you if you're just going to give facts, but I could go a little deeper. What environment do you live in? Describe the animals and plants commonly found in your surrounding. We just studied a whole bunch on the cards, but what's in our area? What's in our backyard? Go for a gallery walk outside. Have them take their paper and pencil. Let's go for a walk. What bugs did they find? What birds did they see? Do they know the names of the birds that they see, right? That's a good way for us to make those connections. And then awareness and consideration of the interactions of plants and animals in the local environments helps humans protect them. So again, an awareness on two sides. We are very cognizant in Alberta that we do need specific areas where animals are protected. So we have safe national parks, for example. We have dark zones for where we have observatories. So what is it that we need to consider when we're looking at that? And how do humans help protect and respect our environment? We might have walkways so that people don't walk on all of the land, right? They want to appreciate what they see, but there's a definite borderline walkway. If you wanted to Google one, there's a great one in Hinton. They have a boardwalk. It's called a Beaver Boardwalk. Goes on for kilometers. You can walk below the water level where the beavers are right around you. I mean, they're 2 feet away from you, but that's a protected area in the sense that nobody walks on the land. They just walk on the boardwalk, but you get benefit of everything that's around that. So, you know, we might even talk to students about what they see in this picture. Why are the animals picketing? Why are they saying more trees, save our trees, 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 right? Why are trees so important to us? Like what's so big about this picture? That's a good starting point. There's 2 books here that you might want to read with them too. The one is called The Earth Book, and that's common in most schools have that book. I Protect Nature. Why should I? Why should I care about nature, right? It's a book that unpacks some of those. And then maybe they could do a Venn diagram. What did they hear in both of these stories, or what did they read about why should I protect Earth and The Earth Book? What was in common in those? What was the message that they were trying to get across to us? We do this in our national parks right now. We have natural walkways that have been built for animals to get from one side of the park to the other so they don't get hit on the highway. There's large, high fences that go around. So you'll find these just outside of Banff, for example. So the animals can walk from one side of the park over to the other side in safety. So can the predators. I mean, it's not just certain animals. Anybody can walk across those. So it just gives them a safe zone in order for them to transfer from one side to the other without having dangers. We also have underwater or under highway walkways that the deer can go under. Anybody can go under again. So any animal can go under, but instead of being over top of the highway, they're built under the highway, so that we avoid the situation of the animal just having to use the highway as their only venue in order to get from one side to the other. We see lots of warning signs like this. This is another attempt to protect not only nature, but us as humans. You hit a moose with a car, that's a serious situation. Those are like hitting a wall. Not only is it dangerous for us, but the animal is likely not going to survive either. So again, what kind of signs do children, what are they familiar with? They probably see deer crossing signs in a lot of places where they live. So even in the cities, we have those situations. There's lots of grizzly bear studies that are being done, and safe zones for grizzlies where you can't hunt them. There's areas for the caribou. Outside of Hinton, again, there's a huge caribou study where they're keeping track of the caribou to try and get the numbers up. There's lots of work being done with people in the cities. They're encouraging you, build a bat house and put it in your backyard. And people are saying, I don't want a bat. Well, but you probably don't want mosquitoes either. You know, it's a benefit from both sides. So there's lots of things that are happening that students can explore and find something that's interesting to them so that they can unpack it. Oops, sorry.
Grizzly bear.
Just trying to get to this one here. When we talk about Mother Earth, okay, respect for Mother Earth. We heard that in our opening video today. Why did they call it Mother Earth? Why is it so important to First Nations and Indigenous peoples? Why are they looking for that? So in the resources section, I've given you a lot of read alouds about Mother Earth. There's an elder that will be talking about that. There's also a resource, a science resource that comes out of BC. It's an excellent resource if you've never seen it. And they give you lots of linkages, not just for science, but for math as well. What is the Indigenous worldview of math? How could we unpack math and make it relevant to our Indigenous students? This one is specific to the Mother Earth and what we're doing in this particular unit. Again, other ones. Here's some other ones where you have, what is Turtle Island? Why do we care about that? How does that connect with Mother Earth? How does that connect with in the Indigenous view that everything is alive and that man is not at the top? How does that change things for us when we build food chains? So these are resource pages. Again, how you unpack those, you might use them as a case study. You might use them as information and then move forward from them. So I leave that to you to decide how it best works for your teaching strategy. Okay, we did that one already. Sacred relationships is one that we will come back to again. It is one that was done in Alberta. All of the work that is done in this for the Indigenous perspective is from Alberta. We will unpack that more when we talk about water. We'll unpack that more when we talk about different kinds of lands that we use. So this one is one that I would suggest if you've never actually watched it, this is a good view just for you as an adult for background information. But there's another one here, the same one that unpacked for us earlier. This one is talking about Mother Earth. So you've got lots of Indigenous resources.
How was our mother?
And I focus on that simply because I know that a lot of teachers have said, I don't know where to find stuff like this. So I will try to embed most of that in there for you so that you have at least enough to start with. All right, scientific methods. Ted, turn it over to you.
I won't be long with scientific methods, but just want to let you know that we are going to be offering separate sessions. Nicole Amory was doing some recordings on scientific methods for each grade, so you can spend some time spending that individually. I just wanted to point out to you, because it is in one of the skills procedures to investigate things. The only time in the curriculum that you're gonna have to go to find what the procedures are in an investigation, because you'll see investigations show up not only in living systems, but in matter and a lot of the other organizing ideas. It's the grade 2 steps of asking questions, making predictions, and so on. So you'd have to refer back to that. As I mentioned earlier, with the direct skills teaching approach, that's what you'll want to do is line it up perhaps and say, here's how we make and do an investigation, do it together, and have kids practice investigations with things that are really exciting to them. You'll notice again, I highlighted the concepts there. Those are the things that that's the language that the curriculum is expecting us to use, is make predictions. So you'll perhaps want to use some of those surface level activities to develop prediction, understanding, what is a conclusion, and so on. And those are available to you on those resources that we showed earlier. Grade 3, the focus is taking that investigative procedure, but focusing in on data. What is it? What is data? How do we make it accurate? Where do we get trustworthy data? Where's our sources? How do we analyze, and so on? So that's what you're looking at more in grade 3 when it comes to computer science.
And I will say to you that that's a close match to your new grade 2 and 3 math as well, right? The same things are happening there, slightly different wording and language, but not much. So this is not just the world of science, right? We're going to tie them together.
You could keep the, we can talk about computer science if you want there, Chris. I do have a slide there that talks about it a little bit.
Okay, so with the computing science, again, we have Ange Deering, and she's going to be creating specific ones that link to, in this case, living systems. So you will be able to go in and look at what are the terminology that lives around computing science. And we want you not to be afraid of that terminology of computing science, because a lot of people are thinking, I don't know how to program anything. I don't know how to make a robot. And that is not what we're doing. Okay, really all in kindergarten to grade 3, it's not even kindergarten, but grade 1, 2, 3, we're really talking about instructions and language that goes around instructions. So all of you, if I say the word algorithm, you might think about, the first thing that comes to mind is math, right? You think, oh, there's algorithms in math. Well, you probably gave your kids an algorithm on the very first day of school. This is our door that we come through. When you come in, this is where you're going to put your boots and your shoes, because this is our rack. I want you to line up, and when you come to the classroom, you're going to do this. You just created an algorithm. You created a step, an approach. So what we need to really do in grade 1, 2, 3 right now is, first of all, use the language that's around it, but then get them to understand that these are what we mean by computational thinking. This is what we mean by creative thinking. This is what it means an algorithm. I'm going to give you an algorithm for how to do an investigation. Here are the steps, right? So that's what computing science is all about. Could it be more than that? Absolutely. Could it be a whole bunch of different programs and stuff? Absolutely. But that is not the intent that you have here. So you can kind of take a breath, because I know that's been a scary one for lots of people. And Ange will have specific examples that you can say, if you were teaching this part of the organizing idea, here's a question you might do, and here's what you could make it look like. That's your computational thinking, or that's your algorithm. So just watch for that to show up in your folder so that you're familiar with it. Hey, Chad, assessments?
Look at the time. We're going to be really brief here. We'll keep on looking at assessment as we go through the other organizing ideas later on in June and with the other ones. But it's well, we have to keep in mind that when we're assessing, we should probably be assessing at each of those phases of learning. We know that when we're going to start a cusp, that we know what to be looking at. There's certain concepts and certain skills that kids are going to need to know to demonstrate the understanding in that cusp. So spend your time finding out what they know. Do they understand the concepts? Can they give examples as a pre-assessment? Do they know the skills? Do they know how to compare and contrast? Do they know how to use a Venn diagram? They do. If know those things through the pre-testing, then you can go on and go to the deep. But if you don't, of course, you're going to instruct at that surface level and then do some assessments. And you could use all the assignments and activities that Chris and I had, your observations about what's happening there, and your conversations with the kids as they're doing activities are going to be really good formative assessments for you. When we get to the deep, remember that's that understanding part where we connect those two. And again, it's looking at their representations, their discussions with them about, it's they're looking at their concept maps, explaining them. Those are ways we can assess at the deep level. And then when we get to the summative assessment, Chris gave an example of a transfer activity that can become a really good, those transfer things become really good summative assessments, because at this point they should have a really solid understanding of the concepts and skills that they're going to need to demonstrate their understanding in a new context. Where a transfer is really giving kids a brand new and unfamiliar context to apply what they've learned in that cusp. I'm just going to show you one other slide here with assessment. It looks really complicated, but it's not. We know that associated with each cusp is that skills and procedures statement. But you need to look at them carefully and what they mean, because it could be something that's assessing something at the surface level or the deep level. And I'll show you what I mean. The green ones are there I've identified at surface level, and I'm going to go to the bottom one. The bottom one that it says discuss First Nation Métis Inuit connection to the environment. If you've just shown that, I mean, there's some examples right in the curriculum guide, and if you just use those examples and share those examples and talk with the kids about it and discuss it, and then ask them later, well, what connections did the First Nation Métis have with the environment? That's purely knowledge. You're assessing knowledge at that point, because they're not creating something new. They're not demonstrating their understanding, just their knowledge. Same with reflect and share actions that can be taken place to protect plants and animals. In the curriculum guide, there's a list of suggested actions. And if that's what you cover with the class and say, here's what this means, here's what this means, here's what this means, and have them to discuss and share what they've learned. Again, they're not demonstrating understanding, they're demonstrating what they know, knowledge. In order to demonstrate an understanding, what they need to do is take something like the blue one, what I have, the first blue one there. Investigate and discuss how plants, there's one concept, animals respond to stimuli in their environment in order to survive. So you could take the investigation process and ask the question, how do plants and animals respond to the stimuli in this environment, use a case study or something, in order to survive? If that, now you're putting everything together and you're doing an investigative, they're going to make a prediction. Well, I think it's like this. They're going to find their information, might be viewing videos, that might be some short reads. And at the end of the day, their answer is going to be their demonstration of the understanding. Yes, animals and plants respond to stimuli in their environments, because in this example I use, here's how it worked. Now they're demonstrating their understanding to you in a new context. And that, so we have to be careful. Anytime we give kids these things to reflect on and to discuss, it should be typically in the context of new context, if you really want them to demonstrate the understanding. That's why I highlighted the different colors. You notice the pink ones there, I said that's still at the surface level. And they represent a food chain. They're just showing you their knowledge of what a food chain is in a local environment. So they can make it the graph, they can make a diagram, but they're just representing it. Unless you give them a new context and say, here, let's watch this video of this environment and the plants and animals in it, and play carefully and show a representation of food chains in that environment. That becomes more of a transfer, more of a deeper learning thing. Demonstrating respect and safety. Again, it's just demonstrating one thing, demonstrating respect, demonstrating safety. It's not combining them and making it a larger understanding. We'll talk more about assessment and how these the skills and procedures work for you, and how to create other assessments that can help you move forward. We're just kind of running out of time today.
So just in the resources, there's not too many, and then I'm going to answer the questions in the chat box as well. Sparkle Box is just a resource we've been sharing. It's great for math, but it's even better for science. You can go in here and it's all royalty free, so you're good to grab it. But you can get a lot of the features, you can get a lot of posters that are pre-made that fit with what we're doing. So for example, a food chain or a food web. So just check this one out. There's nothing special about just going in and finding what you want. I've given you a couple of additional resources, again, that just connect a little bit about the living things that we've done, but it just gives you another place to use if you need some. And this book, and there's a couple here, Is It Living Thing, is a great book. It goes a little bit beyond just what we did in grade 2. It would be really appropriate if you've got some kids who are still a little bit on the fence, not too sure about what the characteristics are. This would be a good book to read. As would this one. This one is great for kindergarten to grade 3, but this is actually more at a grade 3 level, because in here they're also talking about compare and contrast. So they give you a teacher's a guide that goes with it and asks the questions that we might prompt the students with. So again, this is a great book. I have this one and I quite like it. And then I'll share some Indigenous books that go along at any time. This one comes from the Native Reflections. That's easy to order. It's a part of a series, the grandmother series, and it's just short, concise, gives students a little bit of background knowledge. There's also a rubric, a science scoring rubric that I've put in there. There's no requirement to use it, but if you're looking for something that would be maybe in your division that you could all look at together and use this to help sort of identify where your students are at different levels, you might find this one very helpful. A lot of teachers used it in the pilot and they quite liked it. So I'm just throwing it back in here again for anybody who wants to use it. Okay, so I'm going to just stop sharing here for a minute, or stop the recording. And in the chat